So the last type of question that we're going to look at has the word remains in it. And there'll be two methods to do this. You're just going to pick the one that you prefer. It doesn't really matter. If I had a question that said 1/4 remains each hour, okay, you just need to know 1/4 is what it actually is because it's what I currently have. So it's not increasing by 1/4 or I'm decreasing by 1/4 or I'm spending 1/4. It's just what is remaining. So it's what I currently have. Okay, so there are going to be two methods of doing this. I'm going to look at the first method. You can make it an increasing or decreasing question like we did in the like we had in the previous video. So for example, if I have 1/4 of a pizza remaining, what happened to my pizza? Did it increase or decrease if you think I have a quarter remaining? Well, that word remaining implies that I had maybe a full pizza and now I got a quarter left. So that means I decreased it, right? So this is going to be a decreasing problem. Well, how much did I decrease it by in order to get 1/4 remaining? 3/4, right? And I can know that again by typing, and I can just make that a fraction, by saying 1 minus what I have remaining, and it decreased by 3/4, right? All right, so it decreased by 3/4 and I have 1/4 remaining. So that's your B. You can write it like that in terms of decreasing. So in other words, 1 minus 3/4 is a quarter. So that's your B factor. Or you can understand that 1 minus 3/4 is what remains as a quarter. So I can just put it as a quarter as my B. So if I have the word remains, now you just got to be really careful. If it's saying it's increasing or decrease, I need to see 1 plus 1 minus, right? If it just says this is what's left, then you can just put a straight up quarter, okay? Or you can just make it into an increasing or decreasing question. If I have a quarter left, that means then I decrease by 3/4. So it's really up to you and what you're doing. For me, I'm just going to go straight to method 2. I'm going to say if it's remaining, it's what it is. My B is what it is. If I'm increasing or decreasing, I need to see 1 plus and 1 minus. All right. It also works with percent, but remember the percent always needs to be converted. And how do I convert? By dividing by 100. So if you are doing it, making it into an increasing or decreasing, if I have 25% remains, that means what? I started off with a full 100%, minus 25. That means I spent, I don't even know what, let's say it's a pizza. I had a full pizza, right? I got 25% remaining. That means I ate 75%, right? So my decay would be, and it has to be in 1 minus, so it can't be 100, right? So 1 minus 0.75 or 75 divided by 100, which is 0.75. See that? All right. And that means I have a quarter remaining. Or 25%. It just depends if you want to make it a percent or leave it as a fraction. So either way, no matter what they give you, okay, you can write it as a decreasing question, or you can just realize if it's what is remaining, that is my B because it's remaining. Okay, it's not increasing or decreasing by anything. So again, just pick the method that you like, but I'm just going to go with the easiest one, which is going to be method 2. So I'm going to do one example. As I do my example, you're going to do your example. Again, the only difference is if you're given a decimal or a fraction, because you can see they're the same thing, right? You do not need to convert it. However, if you're given a percent, you need to convert it by dividing by 100. That's your key difference. All right, so I'm going to do 6. You go ahead and do 7. Just remember yours is a percent. So before you even do anything, you need to divide it by 100 so you can make it either a fraction or a decimal. A pond has a population, and I'm just going to do the straight up shortcut. I'm not going to do it by hand all the way from the beginning. All right, so a pond has a population. So I have A, B, X. So I'm going to start off my equation with A, B, X, and it's supposed to be F of T, but I'll come in and change that later. So A, B to the power of X. Okay, so I need my initial, and I need my growth or decay factor, and then I need my time. So let's look for it. A pond has a population of 1,200 fish. Okay, so that's my population. That's what I'm starting off with. That's my A, 1,200. All right, it is decreasing. Now, whenever I see that word decrease, I want to assume that it's going to be 1 minus, like I should already be typing in 1 minus because it's decreasing by, right? However, you got to read the question. It is decreasing not by 19 over 20, but it is decreasing each year to 19 over 20. That means it's already decreased and what's left is 19 over 20. So this is remains even though it doesn't have remains in the question. So if it says it's decreasing by or each year by 19 over 20, that means I do 1 minus what it's decreasing by, right? However, it's saying it's decreasing each year to this. So it doesn't matter that it's decreasing, it just gets to this each year. So it's not really a 1 minus problem, it actually is a remains. So just be very careful with reading the question to make sure what it's saying. So copying the function down, 1200 parentheses 19 over 20. And again, I did make a mistake here. Please do not put x. It's a function in terms of t time, so you do have to use t. All right, what would a reasonable domain be? Let's talk about what domain is. So domain is what? Your x-axis left to right. Okay, so starting on the left and going to the right. I already have my function in here, so looking at, oh, I don't even see it. So let's zoom out until I do see it. There we go. All right, so hide that real quick. So there's my decay problem. I can see it does go into the negatives. So this is past this side, but you got to think of from left to right. So if this was not a real context problem, it goes to the negatives and it's all on the right-hand side as well. So this is all real worlds, but it is a real world problem, which means there's some restrictions. So let's talk about the restrictions, and we only care about the domain. So I already know domain is time, right? And then the population is y. So if the domain is time, can I have positive time? Yes. Can I have negative time? No. So automatically I cannot start in the negatives. I must start at 0. At 0, is it defined? Okay, at 0, is it defined? I'm going to make it a table just so you can see it a little bit easier. So at 0, what would this mean? I have 1,200, I have a population, the pond has a population of 1,200 fish. So is 0 defined? Yes. So technically it would include 0. And remember, this semester we're going from this notation to words. So I'm going to write the notation first, and then we're going to write the words. And then the question is, so I can't have negative time. So I'm going to keep going. All right. What's happening to my fish population? It's decreasing, right? Decreasing, decreasing, decreasing. The question is, so 154... I can go on forever, but we've talked about this in class. Technically, with an exponential function, it never gets to 0. This part here is called an isotope. It means it gets very close to it, but never gets to 0. So I can keep going forever, 54 being the number of years. And right now it's at the population at 75.20, blah, 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 right? So I can go on forever, but I don't need to. I know it gets very close to 0, but never actually gets to 0. So I can say this goes to infinity. Now, open because it never reaches it. Okay, now the question becomes, can I include 79.1648, blah, blah, blah? In this case, yes, because it's saying the population of it. It's not talking about the individual fish, just in general, the population fish, the population of the fish. So I have 79.16 in my population. Like it's not the actual physical number of fish. It's kind of like an approximation. So what would a reasonable domain be? All real numbers, because I'm including decimals, all real numbers include all positive real numbers, including 0, because I want everything to infinity, and I want to also include 0. 0 is neither positive or negative. So this will be all positive numbers, including 0. All positive real numbers, including 0. Okay. So I'm starting to write it in words more so that you can understand this notation. What would a reasonable range be? So now I already know I can't have negative time, so I can't do there. So my maximum number population is going to be 1,200. So I already know, but I can't have 1,200, right? So I already know that I'm going to include 1,200 because range is, I'm sorry, y-axis, bottom to top. Okay, so that's why I put the top second, because it's bottom to top. All right, and then the question is, what is this bottom? Well, it never, remember, it comes really close to, but never touches this bottom of 0, right? So this will be 0, open. But now how would I write that in words? It'll just be all positive real numbers up to what? 1,200, because I can't pass that. So all positive real numbers up to 1,200, because now I can't pass the 1,200. Okay. Does the function represent an exponential growth or decay? So we can look at the graph. If it's sliding down, it's decay. Or you can look at 19 over 20. And again, sometimes you need that fraction to be a decimal so you can see it, which is 0.095. So you know B is between 0 and 1. So you can look from the graph or you can look from the equation. We do know that it's decay. Now, depending on which one you want to say, how can I tell? Let's write it this way. B is between 0 and 1. Or graphically, it's a slide. And honestly, this is not an official term, so that's what a slide looks like to me, right? It's a slide. I just want you to be able to recognize it. So really, it's because the decay factor is between 0 and 1. How many fish are left after 9 years? Well, I did go on forever, but here's 9 years. What, and I guess this question should say not how many fish, but what population of fish is left after 9 years. And that's roughly, and again, we can just say round to the nearest whole number, 756. How long until there's 790? There's a population. I'm going to correct these questions for you. How long until there's a population of 796? Let's go look. Oh, there we go. At 8, is this years? At 8 years. All right. So you should be able to go ahead and do number 7. So let me just re-emphasize again. If I have B is what remains, it's the actual factor, but I could write it as an increasing or decreasing. So just be really careful. If it's telling you it's increasing by a certain amount, then it's 1 plus. If it's decreasing by a certain amount, it's 1 minus. But if it's saying it's decreasing each year to this, that's another way of me saying remains. Let me see what this one is saying. Each year, 80% of the material is retained. And again, that's another way of saying 80% it remains. Okay, so there might just be some different vocab that they could use in their question. But go ahead and try example 7. Let's practice.